Hey folks, welcome. My name is Peter Hansen. Hi Rhiannon, good to see you. Welcome to another edition of Data Eng Bytes. We're really grateful to Rokt to host us tonight. We've got a really awesome lineup. It's an all Rokt event tonight, so we're going to be really rocking. Got Corey Bertram, the CTO of Rokt. He's going to introduce himself. And I forgot, Bill Barton, Chief Product Officer and Engineering Officer, is going to introduce himself as well. We've got Kanishka, VP of Engineering at Rokt, taking us through TensorFlow Extended. And then Andreas and Caroline, both software engineers, taking us through how they've built their Rokt Lakehouse. It's going to be a pretty amazing event. I've heard they've got some really great engineering talent here at Rokt, so I'm excited to hear a bit more about how they're sort of rolling things out. There's also some really amazing news coming out of Data Eng Bytes, our data engineering conference that's happening on the 27th of September in Melbourne and the 29th of September here in Sydney. We've announced the venue, which is the Museum of Contemporary Art down in the Rocks. It's going to be a really spectacular venue. We've just let the first 5 speakers know of the lineup that they've been accepted here in Sydney, so it's we'll let you know in due course. Tickets are still $119 each. They'll be going up to $149 once we start announcing the first batch of speakers. So if you wanted to save yourself a couple of bucks, definitely get in there. There's a whole bunch of swag and stuff like that. Anyway, we'll even throw in a set of steak knives. No, we don't do that. But I'll finish with the sales pitch. But anyway, it's really great to see you all. I know it's a bit of a stressful time with a few more COVID cases in and amongst the community, but it's just great to see everyone out and about and mingling. And round of applause to Rokt. I'll throw it over to Seth, who can tell us all about Rokt and get us underway. Thank you.
Cool, thanks Peter. I'm going to keep it really short because I've done a few of these and I've seen a few faces around, so you might know the Rokt story a little bit. And also there's lots of people here to tell the Rokt story tonight with all the details. I might even leave it like this. I won't tell you anything about Rokt, and you have to sit here through the evening and try and establish what we do, right? Just based on what you see from the talk. But I will tell you that we're passionate about the community. We like to give back. We are here as well because we're hiring and we want to see, we're trying to get as many people indoors as we can. We are, I guess, recently raised $325 million US, a valuation of around $2 billion US. So things are going great for Rokt. We have a great trajectory and we're very excited. So what we do, I will leave you to guess. I've said it before, so I'll quiz you all at the end of the night. But I'm going to hand over now for some great talks. We've got Bill coming up now, so I'll hand straight over to Bill, the Chief Product and Engineering Officer. Welcome, Bill.
Thank you, Seth. All right, thanks everyone for coming out. I'm Bill Barton, Chief Product and Engineering Officer. I'm not even done with my 4th week on the job. I started back in June and spent 2 weeks in our New York City office, 2 weeks here. So hold your questions about Rokt for others. Anyway, so week 4. Prior to this, I spent about 10 years at Amazon, worked on Alexa. So all Alexa all the time. Don't ask me too much about AWS or the retail business or media and entertainment. It was all Alexa all the time. Ton of fun though. Got there when Alexa was really just an idea. Spent 3 years before we launched it. Had no idea what would happen. Turned out to be a pretty big thing. And it generates a lot of data every single millisecond. Just lots and lots of data coming out of Alexa. Prior to that, spent some time at Nokia working on some mobile ad servers. Navtech was the traffic subsidiary. Nokia acquired them. And then just centuries of experience before that, as you can see from my hair. Why Rokt? Why would I leave Amazon and Alexa for Rokt? Amazon, definitely a great company. Alexa was a great project to work on. I think many people can work in this industry and not have the opportunity to work on something like Alexa. So I'm really grateful that I was lucky enough to sort of fall into that and then do it. But why Rokt? Well, because Rokt rocks. We've got about 160 people right now across product and engineering. We're based here in Sydney and in New York. Except to summarize some of the numbers about the funding. So we're very well funded. We're profitable, which is nice at this time. And we're hiring across the board, just in case you know anyone out there. All sorts of software engineers, front end, back end, you name it, data scientists, ML engineers, SRE platform, pretty much any of the disciplines. We have roles. Anyway, to wrap up my intro, which I'm glad to be doing because I actually hate doing this, hate speaking in front of groups, but I'm doing it anyway. We'll start off, Corey, our CTO, who's been with the company for years, will come up and talk about multi-cloud. Kanishka will talk about Tensorflow, and then Caroline and Andreas will talk about our data lake solution, Lakehouse. And with that, Corey.
Yeah. Hi. Fuck yeah, Bill. Fuck yeah, Rokt. We're hiring like crazy. Come work here. Work on hard shit. Let's do it. So, why you shouldn't multi-cloud? I was writing this presentation and thinking a lot about this, and in typical fashion, then started realizing I don't want to do this. And so this is really a love letter to me of all the reasons we shouldn't multi-cloud. And we're going to do it anyway. So, you know. And then why do I really even know what the fuck I'm doing? How many of you are multi-cloud right now? Exactly. Exactly. I've done it a couple times like an idiot. Did it at Netflix where I ran chaos engineering, and honestly, chaos engineering only exists to actually be a function of support for the multi-cloud effort and to like actually navigate the multi-cloud effort. Like, you know, just leave a region without having somewhere to go. And then really kind of thinking about the very, very early days of GCP. If you're using Spinnaker today, a lot of that work in the GCP adapters I actually have touched. So, and then I went to Datadog. Huge amount of scale in the time I was there. Was the VP of infrastructure. And then we decided, hey, we should go multi-cloud because that seems smart. Huge fucking nightmare, like nightmare scenario, because Datadog is a data company. And ultimately there's a lot of things you need to be thinking about when you're talking about data. And sometimes you just have too much and it becomes incredibly impossible to actually go multi-cloud in the right way. And then Rokt. I made the mistake of saying multi-cloud at one point this year, and everyone's like, yeah, let's do it. I'm like, fuck. And so we're already multi-region here at Rokt, but we are considering multi-cloud probably this year. Priorities change, things change, so we'll see what happens over the next 6 months. If not, it'll be in January. So, are you really sure you want to go multi-cloud? This is actually a question you need to ask yourself. I really should be asking myself this every day right now. What I mean by this is you really need to understand what it is you're trying to accomplish. I think a lot of people are like, oh, of course we should go multi-cloud. It's cool. Everything just moves. Yeah, it'd be great. Or, everything will get better. It's not better. It's actually really kind of nightmarish if you don't plan to do this properly. People use their customers as an excuse here, like, oh, my customers just asked for it. It's like, okay, that's fine. Make sure that those customers actually matter. Make sure that they're moving for the right reasons as well. Is it a sovereignty reason? Is it something that you can solve by going multi-region rather than multi-cloud? Or is it a residency reason? Like, again, consider multi-region on the same cloud versus going to another cloud. Cloud preferences, really bad reason to go. Like, just because we just like GCP. Don't go to GCP because of that. Unless they're like, here's money. If they're like, here's a lot of money, then go multi-cloud. Fucking fantastic reason. If they're just like, nah, we're gonna give you zero money, it's a cash pit. Don't do it. And it's like significantly increases your costs and overhead. If you think, oh, we'll go multi-cloud, and I'll jab Amazon in the guts and be like, oh, I can go to GCP whenever. They'll just tell you to go. You're not that big. Like, unless you're spending $1 billion a year on Amazon, they don't care. Like, and then you won't actually have negotiating power. Don't kill yourself on this. I see this thrown around as like number one reason for going multi-cloud all the time. Take your data and go. They really don't care. There's plenty of other businesses out there. Same thing goes, actually GCP will like give you a little bit of credit, but even then, like, you have to be spending north of 50 million a year to even begin to like have this conversation. And then the discounts are like, you get an extra percentage. It's not worth it. It's not cheaper to go multi-cloud. It's really, really not. There's not, an ease or like, oh, we'll just be able to maneuver faster. Oh, we could just transition whenever. Like, no, none of that is true. There's nothing here that's just like, oh, this cloud is this cloud, or like things just magically work. And then the streamlined platform here. I think really your platforming and tooling, especially when you start thinking about data and abstractions, this becomes the biggest focal point of cost for you. Flat out. You're going to spend a lot of time, a lot of energy, a lot of effort, and then you're going to be, retraining your staff. Like, we spend a lot of time here really getting our staff up to speed with Amazon. I think everyone who's like mostly certified in this case, like it's actually pretty impressive, and so therefore we're like really efficient on Amazon. Going to a GCP or an Azure, all of that knowledge goes up the card, and it can be painful, and it can be even more so. It can be a security risk. Your security team is going to hate you if you don't multi-cloud. Mo, are you here?
Yeah.
Sorry, Mo. Your security team has really got its work cut out for it. It's twice the footprint. It's different. You might think you're configuring something the proper way, and instead you're opening it to the entire internet. And you're just like, oh, I did it. And it's like, uh-oh, there goes all my data. Scale. I see again, performancy and latency thrown around like, oh, just so much quicker. Like, Amazon's the best. They're like literally the best at this right now. If you're not on Amazon, maybe you should consider it. There's a lot when you start thinking about like, oh, we're going to duplicate data. That requires time, and it's speed issues, and it's money issues, and so like latency tends to go up. You really have to kind of weigh this one. It's depends on your situation, depends on your architecture, but generally speaking, it's worth the conversation. Don't just assume it'll be better. And then team speed again. Over a long enough period of time, I've seen teams become more proficient and be able to kind of operate independently of the cloud. But like realistically, that first 2-3 years is a huge time suck, and it slows things down drastically. In terms of capabilities, everyone's like, oh, well, they've got this or they've got that over there. This is worth a discussion depending on the cloud you're on today and the one you're potentially looking at, or the few you're potentially looking at. But generally speaking, I think that managed services are they're trying to find compatibility between the managed services at this point. If you're already on Amazon, which a lot of the world is, there's really no one competing with them at the rate that they're moving at the moment. Their investment is just huge in every rest. And then, in terms of workload isolation, kind of thinking about, could we put data in this area versus this area and then process it there and be quicker? I do think that is a boon. Certainly if you have that use case, absolutely consider multi-cloud, multi-region. And then resilience. Quite frankly, all the clouds are doing pretty well here except for Azure. Azure's like a nightmare. Don't use it. If you do, I'm sorry. It's a wonderful user experience. It's terrible resiliency. And then architecture. I think you really have to sit down and put thought into what that means for you in terms of multi-cloud. Is it an independent region? Is it an independent infrastructure? Is it one seamless region? Are you trying to distribute traffic globally? There's a lot of questions that you really have to kind of think about in terms of your application and your footprint before you go down this path. I've seen a lot of companies go and isolate clouds and say, well, we have a GCP region and an AWS region, or I've seen them say, hey, we have the multi-cloud and we duplicate data, or sometimes they'll geofence data and they'll say, yes, GCP over here, AWS over here, but they're super independent. It's you really kind of have to figure out what it is you're trying to achieve and the goals that you're planning for. And again, your data, like honestly, if you guys are all data engineers, you're the ones that define this. So be very loud in this conversation. It's easy to write tooling. It's easy to ship containers. It's hard to duplicate data. It's hard to recreate jobs. It's hard to think about access management of that data and secure it. You guys, generally speaking, should be the loudest people in the room. Again, assuming you're all data engineers. And then, in terms of like testing, I would say that, the ability to burst and burst capability, there are some very cheap clouds. You can get some really killer compute on someone like GCP. Worth going that route if you have those types of workloads and you're looking at that type of workload or that type of work in the future. But generally, that's like a really edge use case that I see, and a lot of people like. It's very rare I hear someone be like, "That's the reason why we're doing it." TLDR on this one is like literally question every decision and then constantly question that before just jumping into this. Quite frankly, again, slide deck is more for me than any of you. So great, you're going to do this. Minimize your scope. There's like really important things you need to get right at the beginning. And again, being in charge of your data and being on your data teams, this is for you. Think about who has access to what, who needs access to what. Make sure you get this locked in before anything else. Because again, this is where your security team comes in and loses their mind. If you're just like, surprise, GCP, and they're like, what the fuck are you doing? It's like super, super important to get this and to nail this. All right, and then think about your data assets. How many of you know all the shit that's in your S3 buckets? Yeah, exactly. This is actually a huge, huge problem. It's one you think you know, and a lot of teams think they know. They're like, oh yeah, we got this. And like, you have no idea what your team has stored or what's out there or how much of it is critical. Like we've moved beyond the days of like, oh yeah, we have a computer in the corner that stores the keys for everything. Like, don't turn it off. But now we've like, oh, we have this data. It's in the corner. It gets access like once a month, and it runs this one job that isn't a Lambda that like, no one knows about. And it like that's what powers everything. This is super, super important. Do your homework. Dig in. Be lab. Like again, if you guys are in charge of the data at your teams, this is for you. You should be doing this anyway, quite frankly. And if you're not, like you're probably not watching spend, or maybe your scale is just not there yet. But as you reach scale, this becomes a huge nightmare if you don't have a plan around how you're accessing data, where you're putting it. Our team's going to talk about it today. We've gone through a pretty giant evolution in the business around how we think about data and how we store it. And that work is absolutely essential for us to make a move like multi-cloud. So schemas, who owns it, where's your derived data, what is important. This is the other fact. Like don't move everything. In fact, the reason to go multi-cloud and multi-region is to not move everything. Keep data isolated to some extent if you can. It's not worth just copying everything over. It's super expensive. Egress out of clouds is purposely expensive, so don't do that. In terms of cloud resources, like you know what? It's one thing to go multi-cloud because hey, we want to use data tooling and we want to use certain services or EMR is cheaper there or compute. But like if you're going to run the entire application, you need to be doing that inventory as well and make sure your teams understand that and really understand like what is our footprint? What is the bare minimum to run this thing? Rokt's getting pretty big. We have thousands of repos. We have thousands of nodes, like tens of thousands of containers. What actually is required in the path? I don't know if anyone knows this anymore. Like we'd be like, oh, we moved 90% of them, then we find out where the gaps were. It's not great. So we have to sit down and do an inventory. Everyone I've seen has to do this. It's an exercise. It's an exercise that's like worthwhile. We should be doing it more often. And then again, think about your architecture. Like I said, depending on what your goal here is, this really truly defines what it is and your strategy around multi-cloud. I would say, there's a pretty big boom to moving compute. It's harder to justify moving data. It really is. It's very, very hard with the amount of data that we are, generating today, the growth of data across the globe. This is one of the things where it's like, if you're a huge data company, stay in one cloud. Negotiate your bill on your data transfer between regions instead of going between cloud providers. And then security. There's one aspect of this. I have seen a company go multi-cloud because of compliance. I've seen a region selected because of compliance in Europe for certain laws and data sovereignty rules. So if this is you, then great. You have a really strong use case, but then congratulations for some hell of a ride. And then the question is like, how do you do all this? Where do you start? I put this slide in because someone asked me to. Someone's like, hope is not a strategy. I said this at some point, and then they drew a picture and it's weird. Honestly, this is a tooling problem, and what I find at most organizations is that tooling, operates for one set of users in the operating space of your services, et cetera. And then there's a whole different set of tools for your data and how you think about managing data, where to move data, and you really have to spend a lot of time getting in there. You spend take a quarter or two and layer your foundation. It is worth it. Get it right. Include your security team. Do all these exercises. Do the homework. Figure out what your bare minimum is, and like make sure you get that nailed. Involve your security team. Like so many people, like we went to GCP and like they treat it like a toy. And it's like this is how you end up with a huge security breach. Don't race. Slow down. Include the right people. If they don't have time, wait. And then, obviously you have to really think about abstracting away everything. It's such a nightmare. There aren't such thing as equivalent cloud services. I don't care what anyone tells you. Like S3 maybe is the only one that is even remotely close here. Everything else has nuance. Everything else has different default parameters. Even like databases, RDS versus like Cloud SQL, wildly different default parameters. And so like what you get in terms of performance, if you think about it, you have to really dig into the details here. Something to be mindful of, it's not one-to-one. Your tools need to think about this and abstract it, because otherwise you're gonna have huge performance bottlenecks, you're gonna have huge like access management problems, and just like you won't be able to debug anything. The other one that I didn't add here is around like observability. Honestly, if like you rely on one of the tools from one of the cloud providers for all of your observability, you have to not do that. You have to go to a different provider. You just need to be thinking about, how do I get visibility across clouds? How do I make that uniform? How do I make sure my metrics are there, my dashboards, my monitors? You really don't want to have to be having two different sets of things that you have to manage between clouds. It's a nightmare long term. It's a nightmare for every developer in the business. Avoid it at all costs. And then avoid the silos. And I caveat this one where necessary. So like I said, if you're saying, hey, we want to take advantage of GCP and all their ML tooling and their tensor processors, do that. Awesome, great. Silo your data, perfect. But if you're like, hey, we're just going to run everything everywhere, we're going to do that, like it creates, there's a lot more work that's involved in it, but it does give you the flexibility long term if you think about properly about multi-cloud. Again, if you're just using it for data, great, but then once you try to do more with it, you will hit a roadblock, or you will create security nightmares for yourself. What I would say is, if you have a strong use case for the Kool-Aid, there's some really interesting managed services coming out of clouds now that like maybe you shouldn't build a feature store. Hi friends. If there's like tools that you can use within these clouds, do that. Like, don't be afraid of the Kool-Aid. We drink it like crazy on AWS right now. We have to undo a lot of that, but ultimately, like, it's gotten us very, very far, and there's some interesting things happening in other providers that we want to explore. And so I would say that this is a pretty good thing. And then, hey, I put a slide from the data side. In terms of when thinking about like modeling and whatnot, I would highly, highly encourage your teams, if you can, to think about building your models and queries with a multi-cloud in mind. You think about how you can make localized derived data within each region and within each cloud, and then pull it back into an overall model. Moving derived data generally should be much cheaper and easier than trying to say we replicate everything. Costs get out of control. We generate so much junk, dead data. And I'm not going to sit here and say like you should clean up dead data, because like no one does. You're just paying up. It's asshole tax. But generally speaking, if you can keep your derived data clean, you can move that with much more ease. And then localize everything. Like I said, keep these things, use your federated models, combine them into one, and then like move that around. That's all I had. I only had 10 minutes. I hope I got through everything I wanted. Any questions? If you want to talk about this in real and you're actually thinking about doing this, one, don't, but two, like, come talk to me. Sound good? Great.
Sorry, do you think that at some point of time, just a crazy idea, the cloud companies will become like electricity companies where they will be bidding on a daily basis for?
Absolutely not. Absolutely not. Like, how would I charge you, right? Like, no. Private market, man. I'm gonna take you for every dollar I can get. I'm gonna give you value, but I'm gonna take you for every dollar I can get. I really doubt you're gonna see companies like HashiCorp where they kind of build their own software that you have to maintain on top of it. I think generalized compute makes a lot of sense, but that's not where they're making the money. I can tell you that's not where our Amazon build goes. Our Amazon build goes into managed services, and like they're good. They're like really, really valuable to the business. They're able to do some amazing things. The generalized compute is like a fraction of our bill in comparison.
I've got to ask the obvious question. You gave many reasons for not going multi-cloud, but you also said it was on your roadmap for 22, 23. So
Yeah,
which of those areas?
money. We have customers that are like, we don't like certain cloud provider, we want you to do this, and like financially it does make a lot of sense for us to do. I think the use case for that is so small, and I think it's dwindling. I don't think that that narrative is going to last much longer. If you look at what's happening in even in the US with Amazon, like Amazon or AWS might get split out, like they might be forced to get split out, and then like that argument starts to hold less and less weight. I would not let a customer push you around like that if you get a bulk and avoid it. The one example that I've heard now 3 times in my career is like, oh, but Walmart. And Walmart doesn't want their data on AWS. Like, Walmart actually will push it. You can push them over on that in like a heartbeat. They really don't care anymore. It made like a lot of sense 5 years ago. It doesn't make a whole lot of sense now. And I've realized that like it's a lot of time, energy, and effort wasted. So like avoid like what is a non-issue. But yes, we are doing it. We're mature enough as well with where we are as an organization to be able to do this fairly effectively. A lot of organizations I don't think are. They're not willing to make the investment. Anything else? All right. Well, with that, I'm going to hand it over to Kanishka, and he's going to talk about Tensorflow. I don't know which subject this is.
We need a joke, Seth.
Need a joke.
Yeah, we need a joke.
I don't have a joke. All right, from Corey's talk, what do we do at Rokt? You can't answer, you won't. Maybe grab another beer from the bar. Come on. You're good.
Do you have it as well?
Sorry.
Do you have the same slides?
Not yet, no. Do you want to share that? Simon, perhaps you can tell us more about data-eng bytes and why we should all buy a ticket.
That's a great question, Peter. How long do I have to fill?
A minute or two?
Over. If I could maybe look around this room and just kind of guess that the majority of the people in the room have a job title that involves the word data. Show of hands. Data engineer, data practitioners, data observability. All good. I know what I'm doing on September 29. Peter, what are you doing on September 29?
Going to data-eng bytes.
So this would be the place to go. If you're interested about anything data observability, data engineering practices, cloud technologies, understanding the implications of data, we've got some fantastic speakers on 29th of September. We've got the MCA, is that right?
Museum of Contemporary Art down in the Rocks.
And an absolutely incredible CFP has just passed. We've already had a bit of a glimpse at some of the amazing speakers who are going to be speaking on September the 29th. And we'd love to encourage everyone in this room, if you're thinking about anything to do with data engineering, if you're motivated to come to meetups such as this tonight, you're definitely absolutely going to love Data Engineering Bytes. It's one day early only. September 29th. It's going to be an absolutely fantastic event. And the tickets are at the incredibly low price of
$119 for the next week.
I can't believe that. For a moment, I thought you said $129. That can't possibly be correct. Anyway, I hope you all consider coming along to Data Engineering Bytes. Thanks.
Awesome. Over to Kanishka. Thank you.
Thanks, everyone. Good evening. My name is Kanishka, and I'm a VP engineering at Rokt. I manage the machine learning and data teams. And since Peter and I spoke last, I thought about talking about TensorFlow extended, but then we decided to talk a little bit more about TensorFlow. So we'll talk about machine learning production and what's the stack in machine learning at Rokt. We'll be divided and talk into 2 parts. I have also a co-presenter. So the first part I'll be taking, and the second part will be taken by Ivan. Cool. So what's on the agenda. We'll explain, hopefully this time you'll understand what we did wrong. So we'll go through what we did wrong, and then what is the role of machine learning at Rokt. Some of the challenges of deploying ML at scale, and then what do we do to tackle those challenges? How do we solve them? What does the stack look like? We talk a little bit about Kubeflow, then TFX, some deployment strategies, observability, and hopefully we'll have some time for questions. All right. So Rokt is a marketing technology platform that is trying to make e-commerce smarter, faster, and better. That is clear to everyone. That you understand what we do now. We also have 5 billion plus transactions served through our services over a year, and we serve 19 global markets. We also have some of the biggest, some of these big brands as part of our partners. But just to give you some concrete examples, I'll go down. So what we do is we use data and machine learning to actually connect businesses together. One e-commerce business, another e-commerce business. And we predominantly work at a specific moment that we call the transaction moment. And I will give you a demo. So, probably network items. Let me see. All right. So let's just say a concrete example. We're going to Ticketmaster, which is one of our partners, and I want to buy a ticket for an event this time. This is a Justin Bieber concert. And I will go to the ID package and get 2 tickets. Let's go to this. This is the actual checkout process. That's what it looks like. And you see this, Rokt will actually choose to show some outsourcers. So in this case, you're during the transaction moment, Rokt will decide whether to show an outsourcer or not. In this case, it's, do you want to pre-book your parking? It's from a third-party provider. It's called Parklist. It will decide what's the order of the parking providers, which offer should be shown first, which second, and third, as opposed to Ticketmaster, hardcoding these things. So this is one thing that we did, and this is all decided by machine learning. And if you go to the next stage, is Mark here? No.
I'm in the corner.
Over here.
Oh, there. Mark is the engineering manager who actually kind of builds this system. So.
Go Mark!
Good Mark, yeah. Trying to make sure listening to my talk. So then the transaction moment is when you actually made the purchase. You're in the right mindset, you've taken your wallet out, then we will also show you a recommendation for another offer. So in this case, you want to claim a free voucher, or you want to get 16 free meals for HelloFresh. And if you actually click yes on this, it will send down the file of HelloFresh. If you said no, then you might be shown a different offer from Google. You want to sign up to Google, and could be a few different offers. You can claim it, you can close this, and that's pretty much how Rokt works. Hopefully that clarifies things for you guys. And all of those offers, what happens is that some of your data will be sent to Rokt, and then Rokt will make a decision to show which offer you saw that was on real time. So what are we trying to do with machine learning? Machine learning and Rokt tries to optimize for 2 different objectives. One is it tries to optimize user experience. It tries to optimize revenue for us. Every time someone actually engages with the offer, we generate revenue. But at the same time, we try to optimize for advertiser outcomes. So the third-party businesses that are actually whose office is shown, we also try to optimize for the outcomes. And how do we do this? This is all done, the predictions are all done in real time. We send some demographic information as well as contextual information. So demographic information like age group, gender, device type, that kind of stuff. Context, what did you buy, how much did you pay, where did you buy it from, this event is, from Ticketmaster, for example. And this, the behavioral information as well as like, does someone click on this, does someone just see it, all that goes into the model will actually pick, match the right offer to the right experience, and then decide that that's the for the user. And we currently have like about 20 different models around production, over 100 different features, very much the better that we process. As you can imagine, we have a lot of, this is basically a two-sided marketplace because there's one side of the marketplace that supplies the traffic and the other side of the marketplace has the demand for that. So every time someone goes to Groupon and makes a booking or buy something, then it hits our API. Someone goes to Ticketmaster and buys something, it hits our API. So a lot of data is collected, so very much data collected. About 60 million predictions or inferences are made per day. So the scale of the challenge is huge, and not many people actually get to work with such interesting problems. And as you might have seen this, who here's work with machine learning or machine learning? 1, 2, Ravi, you're Mikey. Anyone data scientists here? You guys might have seen. The rest of you guys are data engineers, I guess. Machine learning code, usually data scientists build machine learning code, which is the training part, and deploy that rather than their Jupyter notebooks or our environments. But that's just a small, very, very small part of the whole problem. You have the configuration, you've got data collection, you've got a whole bunch of serving infrastructure, monitoring, everything else that needs to go there. So how do you solve this kind of problem? So this is where we will go through our stack. The first part of the stack that we use is Kubeflow. And Kubeflow is a platform created by Google that runs on Kubernetes. It basically follows the three principles that we've got here: composability, portability, and scalability. Composability means that it allows you to break down your ML pipelines into smaller components and code so that you can reuse those components. Portability allows you to run it anywhere. So it just kind of ties back to what Corey was saying. Your ML, when you build your systems and ML models, making sure it can run on different clouds. So this allows you, because it runs on Kubernetes, you can run it on Google Cloud as well as AWS and Azure, anywhere. And then scalability, since it runs on Kubernetes clusters, you can allocate as much RAM, CPUs, GPUs, and storage as you like. So this is kind of, it maps the different composability, portability, and scalability to different, I guess, what it means. I will go through this and we'll see this on to the next slide. The workflow, machine learning workflow is pretty much standard. It's across, I guess, when you're building any pipeline, it looks the same. But what we've done is we have configured our Kubeflow clusters. We've got 2 different clusters. Has anyone worked with Kubeflow here, or? Yes, only enough people. So I guess how many people have used Kubeflow? Some of you might have used Airflow, some of you might have used MLflow by Databricks. So Kubeflow is similar. Allows you to, it's an orchestration layer that allows you to run ML pipelines. And one of the things that we have done is we've created 2 different classes. One of the classes is for experimental work. You can set up notebooks, you can run your own experiments, you can do some exploratory data analysis, data collection, you can do the full pipeline there. And then we've got a separate production cluster where you can deploy your production workloads. And then From there on, there's the model serving, and then there's a whole bunch of observability and logging that happens. In the next part, how do we actually break this down? How is the model written, and then what are the different components of the model? That's done in TensorFlow, and specifically with TensorFlow Extended. So in this part, I will mark to invite Ivan, who will get you to the next level and go to TensorFlow Extended. So, Ivan.
Right, thanks, Kanishka. So I will talk through the TensorFlow Extended that our teams are implementing to develop the end-to-end machine learning model. So essentially, as Kanishka mentioned, Kubeflow unlock the limitations in terms of the infrastructure, allow us to build extensible scalable machine learning. And then we can start building these little pipelines on the Kubeflow and to orchestrate different steps of the machine learning. And I think not many people have built machine learning in this room, so I will briefly talk about the steps. So usually to build a machine learning from scratch to the production, we need to ingest the data from the upstream system, and then validate the data to see if the data has a good quality for the model training, and then transform the data into a format that can be consumed by the machine learning model, and then do the model training and evaluate the machine learning locally to make sure it actually meets our requirements of the model performance, then publish the model into our online services. So then that will be published to a staging area and then picked up by our online service to do the real-time inferencing. So this is a quite standard a process of develop a machine learning model end-to-end. However, although we have the infrastructure to support the scalable machine learning training, the next question for us is, if you ask the question to 10 different machine learning engineers, how you build a model to follow this process, you may get 12 different solutions to do that. So how can we actually support our machine learning engineers to do innovative work, focus on the researching and the value-added work rather than some replicated, duplicated works by building those pipelines? So that's how we start looking into TensorFlow Extended. So when we talk about TensorFlow Extended, if I need to use one sentence to explain it, it's a framework used by Google to productionize the machine learning end-to-end pipelines, and especially for the TensorFlow. So teams are using building a lot of instances of the state-of-art deep learning in the team. So and we are mainly building our deep learning model in TensorFlow. That's why we believe TensorFlow Extended is actually a really good add-on to our team's tech stack and to use it to productionize our TensorFlow model. So TensorFlow Extended is providing all those components, standardized the components to support our machine learning engineers to do the normal jobs and reproduce the jobs without too much manual work, so they can focus on the innovation work. So I will briefly talk about each component one by one. So the first part of the process, as I mentioned, our engineers and data scientists, they need to ingest data from the upstream system. Those systems can be like data lake, can be unstructured data, can be something sitting in the S3 bucket. And then they need to validate the data to make sure the data is actually meeting the quality requirements for our team to feed into the machine learning model. So how TensorFlow Extended is helping that? So there's a component called example gen. So this is the first component that allow our data scientists and machine learning engineers to call that component to ingest the data from different data sources and convert them into TF record format. And that's actually a sequential binary record file, and which can be then effectively consumed by the following components for the machine learning pipeline. And then we are also leveraging three components called step gen, schema gen. Those two components are basically help us to learn the data we are ingested from upstream systems into our machine learning pipeline. It will produce the distribution of different features, for example, and also infer the actual potential schema for the data. So those information will be exported to the S3 for our like monitoring and observability in later stage. And what's also useful is example validator. So this component can help us to identify any outliers or any data quality issues within our upstream data source. And so we can actually be notified and alerted early enough before we proceed in the following steps of the machine learning pipeline. So those components can help us. We don't really need to review all those components every time when we introduce a new model to our team, and it actually saves a lot of time for our team to do the data ingestion work for the machine learning pipeline. So those are two examples from the TensorFlow extended pipeline. When it ingests the data, it will generate that like page to say how many zeros in that column, particular column, how many non-values, and what's the median, what's the scale look like, and if there are any new features identified for the new for the existing data source, it will tell us and alert that's the new columns that you need to be aware of, that which may change your model training in later stage. Cool. So moving to the transform stage. So when we before we feed our data, ingest the data into the model, we need to do the transformation for the feature, and to make sure they are learnable by our machine learning model. Those transformations can include the scaling, standardizations, and or even more innovative methods implemented by our machine learning engineers. So what transformation does is it helps us to do the transformation automatically, and it also actually exports the transformation method to our online serving part, which means it will, when you do the online serving, in later stage, it will apply the same transformation. Because one of the very large, very challenging issues happens in the machine learning world is when you train a model with the certain transformation, how can you make sure there's no discrepancies between online and offline data transformation in later stage? This has been a very large challenge for us, and transformation actually perfectly solve this issue for us, because we will be always applying the same transformation offline and online. So, cool. So once we've done the transformation, the next step is the training. So TensorFlow Extended also provides a trainer and a trainer. So trainer is essentially at Rokt, we are training machine deep learning model with millions of weights and hundreds of hyperparameters in it. And whenever there's new distribution or data coming in, or the market dynamics happening, or even we add more information to the model, we probably need to return our hyperparameters for the model. And the trainer is actually a component provided by TensorFlow Extended to help us automatically return our model hyperparameters over time. And then trainer is essentially the wrapper of the TensorFlow library provided by Google to help us to train our deep learning. So it's quite straightforward. So what's actually useful is for the later two components here provided by TensorFlow Extended, evaluator and infer validator. Evaluator will, after we train the model, evaluator will grab our model and do the local evaluation and export the local performance for the model. So in that case, our ML engineers, even in the production environment, they always have the visibility about every single training pipeline, how the model is performing. If the performance is deviates a lot since compared to the last run, there might be something happen, and we need to review our model pipeline. And infer validation is another magic one. So what it does is it actually takes your latest trained model and creates like a sandbox environment and test if we can load the model into the sandbox and see if it can be serving or online serving. And only when the evaluator and the infer validator is passed, then we will actually move to the next part of the pusher. And pusher is actually pushing our model into the staging area, and which will be picked by our online services for the real-time serving. So essentially, those if we look at the end-to-end like offline training pipeline from the TensorFlow Extended, they provide a lot of extra components to help us to secure, make sure we can always push the quality models into the real time before it's actually serving to our clients. So, and this is how it looks like in Kubeflow and the actual training pipeline. Cool. So once we actually train our model and push to the S3 buckets, then we will we also use like TensorFlow serving as services to do the real-time serving. And it's actually also deployed on the Kubernetes to make sure it's actually all scalable and replicable. It's like stateless services for model serving. So it will be loading the exactly the same model from the pusher and then apply the same transform to the online data. All right, so so when we talk about when we push even after we push our model into the online, it's not end. So we need to return our model when there are new data coming in, and we need to keep iterating our machine learning as well. So for a champion model, you are also not safe. We as a team, we are actually developing all those challenging models over time. And they are actually trying to challenge our champion model, make our model performance better and better over time. So how we are doing that at Rokt is we actually doing an online A/B experiment. So for example, Alex, he developed a new model, and we've seen like good enough offline experiments, and then we will the pusher will be pushing the new model into the like S3, and TensorFlow serving will be picking up that new model and assign, for example, 10% of traffic. And then if we see the 10% of traffic from this model is performing actually better compared to our champion model, we will promote it to 20%, 50%, and eventually, if it beats the champion model, we will actually promote it to be the champion model. Then it will be challenging by a following model. That's how we are actually iterating our machine learning model and at Rokt. Cool. So that's all the like end-to-end from the TensorFlow extended pipeline. So next, I'm going to talk about something boring but important. Cool. So as you can see, even we are trying to automate a lot of jobs for the machine learning development at Rokt, including using the TensorFlow extended and also trying to use the Kubeflow to orchestrate pipeline. Still, across the whole like process of the machine learning development, there are huge uncertainties, and those uncertainties can never be eliminated or automated. For example, when we ingest the data, how can we know that data will be valuable or they are meeting a good enough quality model training? And also, when we train the model, how can we make sure the model architecture is actually valid and performing the same offline and online? When we actually publish online, how can we make sure online data is expected as offline data? What if, for example, Elon Musk posts something on Twitter, we change the market dynamically entirely, our model will not be like valid anymore. So in that case, observability for machine learning is critical, and by having those visibilities across the machine learning process can help us to identify the potential issues immediately, and the team can pinpoint into those issues and react quickly. And anyone want to guess where across this process where we should put our visibilities on? Yeah.
Everywhere.
Everywhere, yes. Yeah, essentially everywhere. So when we talk about observability of machine learning, so the first come to mind is the model performance. So including the latency of the model, response time, and also the model staleness. If our model is like over than two days old, it cannot capture the latest trend from the market. So it will we may expect to see some model degradation and which could lead to the worst customer experience to Rokt's customers. And also, that also includes the model like fairness. So sometimes even we are improving our model, optimize our model performance towards the network-wide performance. Does it mean that will be always good for every single publisher or partner to Rokt? So that's also we need to check. And also, when we talk about model performance, it's not only about maximize the revenue. At Rokt, we also care about the reputation of our partners and publishers. So if we are suggesting we have bias on a certain small cohort of our customers and recommending something totally irrelevant to them, that will cause not only cause the revenue loss but also cause the reputation loss for our partners. So those kind of visibilities we want to bring to our model performance side. They are also drift risks from the online data, offline data. What if we see suddenly increase the proportion of the mission value for certain features, which is very important and predictable to our model? We need to identify that and be notified as soon as possible. Otherwise, it will actually damage our model performance, not only in the offline but also online. And that also relates to the data quality from upstream system, what are missing value, duplications, and the change of the distributions. What if they are, we are expanding our market to the multi countries, maybe US markets has 90% of market share before, but now it becomes 70% of market share. Can our model actually react to those distribution changes from our clients? And then model evaluation, also the machine learning platform. How can we actually make sure our pipeline is always cost effective, for example, which is Corey might be concerned a lot. So are we actually spending too much infrastructure? So how can we make sure we are using it effectively? So those kind of observability, not only from the modeling performance, but also from infrastructure, also business side. They are actually all everywhere across the machine learning end-to-end pipeline. So how we actually capture those information at Rokt? Essentially, we are actually bucketed them into a real-time metrics, batch metrics, and also the model pipeline metadata. So when I say batch metrics, those are the metrics we want to look back into 30 days, 60 days to capture the seasonalities. And when we do the A/B experiments, to make sure the new model we are released to the market, they are robust enough. They are bringing the fairness to our partners, every single partner, and also the customer experience. So those batch metrics we are using dashboard like Tableau to run batch scripts and pipelines to generate those metrics, so we can have the visibility into the model performance at a longer period. There are also real-time metrics like the latency, QPS, and also fail rate, and uptimes. All those real-time that we want to react immediately when something happening in the real-time environment. They are actually exporting to our Datadog dashboard. We also have RDBMS and S3 to capture all those machine learning pipeline metadata, including the artifacts about our model. So whenever we want to compare the models and the pipeline versions, we can look into those stories. So in that case, we are trying to we can't avoid all those uncertainties across the machine learning development, but we want to capture as much as the information we can to make sure we can always provide the best experience and optimize our modeling in the right way to our customers and partners. Cool. I think that's it. Any questions? Yes.
Can you talk about if you do any sort of bias testing, and if you do, then what strategies do you use? Any bias testing?
Yes. Right. So that's actually a very good point. So essentially, we are currently leveraging Tensorflow extended component, which is the evaluator. So whenever we train a new model, introduce a new features into the model, evaluator will not only return the overall performance of the model, but it will also like return the performance for certain cohorts, like certain partners, certain age group, certain people. Then we can always see, even we are increasing the overall performance from the model, does it mean will there be any like degradation for a certain group of people or certain region of our partners? So in that case, we can always like look into like not only the broad view but also a more detailed view.
So does mean that you're actually sacrificing the model prediction power just to keep it unbiased?
Yeah, I think there will be always like trade-off, and that's a very challenging problem actually. So model explainability is being like challenging problem in industry. A lot of cloud providers, they are trying to provide native solutions to that, and to us, so it's more like how we link to our business metrics. So when we will always want to maximize the customer experience. So there will be certain rules that we don't really want to provide irrelevant like offers to our customers, and also if we don't really want to recommend, for example, like a gambling product to someone less than 18 years old. So those things maybe so those recommendations about ethical issues we want to avoid of course. But sometimes when we make the machine learning model, those explainability can expose those issues for us. But there's always a trade-off. If you are not like hitting those red lines or certain rules, there will be performance fluctuation, but we will have a threshold to make sure the offer is relevant to the customers. Yeah.
So when you have this pipeline,
Yeah.
and let's say you're creating a new model, okay, does mean that right before the pusher, there is some sort of manual evaluation, or it's hitting some business rule that the bias is too strong, so red flag for evaluation. How is it?
Yes. So there are two parts. One is automated way. So through evaluator, we can compare the performance across certain cohort, and that will trigger that can trigger the automatic alert for us. So our data scientists can look into that. There are also like hard rules, so there will always be human in the room. So which is not actually showing this chart. So after the model prediction, we also have the option like surveys and ranking surveys after that, which will be applying those selection rules to make sure even the machine learning is suggesting something, we are always actually aligned with our business requirements as well. So.
Okay, another question, sorry.
Yeah.
This, you mentioned A/B testing.
Yes.
The promotion and degradation of the rank, is it automatic or it's again human intervention?
So it's traffic split is automatic, and but when we do the reporting and analysis, we always have data scientists to look into the performance between models. There's no single metrics we can follow. We always look into the click-through rate, revenue, for example, and also the share of voice. There are multiple metrics we want to make sure our model is robust enough before we make the decision to promote it.
So
it's manually done. Manually, someone will go and change that in a config and say now from 50% to 75% or something like that.
And then when you've been presenting what Rokt is doing, I noticed that there is a sequence which offer to show first. Does your model decide on the sequence, or it's in terms of competition as well?
Yeah, you're actually asking a lot of insightful questions.
So we do
consider the orders of the offer. So.
Let's just say we have a proprietary algorithm, which we've patented, which is called a single auction. That's responsible for actually selecting the order of the offers, which offers shown at which slot.
So not only which offers, but as well the sequence.
The sequence, like which slot, and that's all done in real time. So you get a whole bunch of ranking, and then that's done. The whole ordering is done based on a proprietary algorithm. That's pretty much within a few hundred milliseconds. With like thousands of like candidates that you have to select, a lot of different combinations.
Round of applause. Thank you.
I'll introduce them. introduce you, Andreas? What do you want to do?
Yeah.
Right now we have Andreas and Caroline who will be presenting Lakehouse. So a round of applause for Andreas and Caroline.
Do you have that one as well?
Sorry, guys, just need you. If you have any questions about bias, model bias, you can ask me that. We can talk about it.
Gotcha.
Right.
Yeah, for it.
Hi everyone. Delighted to be here. Thanks for coming tonight. So presentations are already done, but I'm Caroline, software and big data engineer at Rokt, and I'll be presenting how we built our data lake at Rokt and how we evolved into a fully functional lakehouse along with my co-presenter Andreas. So the agenda for today is just to give you a quick overview of what was the previous iteration of our.
Excuse me, can you
Yeah.
talk closer?
Sure. Let me adjust that.
It's a bit tricky.
Thanks.
Cool.
All right. Yeah, so I'll just be going through the last iteration of our data lake architecture, a little bit of its overview and limitation before we started implementing our new lakehouse architecture, so brand new as of 2022 and our current development, but already like a lot of good outcomes from it. We have been through many iterations of our data lake architecture, so I won't go through all the past iterations. I'll just compare the previous and last one. And then Andreas will talk about the new lakehouse. Yeah, so a little bit about the data ingestion of our architecture. So at Rokt, we do produce a lot of events, and we ingest many events. So on average, about 500,000 per minute, which can pick up to 750,000 events per minute as of early 22. We have a lot of producers. We have what we call raw events, which may be events that we generate based on signals that we get from the data, others that we derive or enrich based on additional metadata that we collect through the process of collecting and ingesting events and through the user flow of transacting with Rokt. So all these events are currently ingested into our Kafka cluster, and they are made available in S3. The easiest way to make it available in S3 via Kafka is to use an S3 sync connector, and that's what we've done. This data is also loaded into our data warehouse, which is Redshift on AWS via a custom application. And mainly we have, well, in an ideal world, we would have our data warehouse for BI use only in order to provide powerful analytics for business analysts. And we would have S3 for most of our use case. However, so far with this, if you can call legacy architecture, S3 mostly remained a cold storage option for other debugging purposes, and hasn't seen wide adoption at Rokt across all our internal consumers. Instead, most consumers rely on Redshift, which causes a few problems, as we're going to see a little bit later. or now. So just an overview of the main data consumers that we have from our Lakehouse, and like mostly from Redshift actually. So we have business analytics, as you would expect, big analytical queries, Tableau, and data visualization for analysis, which are all good and legit. And then we have maybe not so legit use case of Redshift, such as Tensorflow, and a little link to Kanishka and the previous presentation with Kanishka and Ivan. I think in the slide of the previous presentation, it was just like a little box called, raw data ingestion or something. So yeah, Redshift. And then we have other jobs. We have some large data extraction transformation, maybe on Apache Spark, that are using data tables on Redshift as their main source of truth. We probably have we do have a lot of other ad hoc use cases, maybe some unload jobs, even maybe some periodic unload jobs from Redshift, which outsourcing data that could be sourced from someone else. So all these create problems. It means we have too much load on our Redshift cluster, which has limited resources to use. We have too many concurrency issues, too many people, too many applications wanting too much data at once. It creates contention on resources at any time of the day. It means that critical queries may be delayed, and in particular, we may want to prioritize some queries that are made by our data analytics team because they are relevant to business insight that needs to be delivered in priority. But in some cases where workload management hasn't handled this appropriately, reports may be delayed because of other big jobs that are running in the background. So it's harder to guarantee the execution of critical loads when you have so many use cases of Redshift, which it's not designed for. And why are we running all these loads on Redshift? You would say, well, we have a legacy, our current data lake architecture has some limitations. Or should I say, our previous data lake architecture. As you've seen, it's not really usable in a big data world because we are mostly using a C connector from Kafka to S3, and it means that this data, which is growing and growing, and which is like in large scales, is not very usable, which I will come to the reason why in the next slide. But just as in an ideal world, we would be able to have the main four following capabilities, which are present on the slides, which are data analytics. So we want data available for analysis, and we want analysts to seamlessly work with that data, which is reliable, and they can perform fast queries without contention. We would like to have easy data discovery, which means it's easy to find out the data, the origin of data, and understand it in its cold storage format on S3. We want easy application development, so we need, again, data to be easy and fast to access and to load in applications for small and big consumers alike. And we want change data capture or data evolutions, changes that are backward compatible, and consumers do not break on the data model change basically. So what do we have? Well, for data analytics, we don't actually provide a reliable data warehouse which is able to perform these queries that are business critical fast if we abuse Redshift too much with resource contention. And so our data warehouse had become a little bit too much of a multi-tenant data warehouse with shared resources. And it had become difficult to scale computing resources independently from storage. So yeah, this was like a little bit of a problem for data analytics. On the data discovery side, well, we're not using S3 as much as we should because we have lack of metadata catalog for our S3 data. And this is essential for human to understand what kind of data is stored on S3 and what kind of fields are available in files, especially if they change. And we have a lack of tooling integration for machine to be able to efficiently read the data on S3 and make sense of it, and also be able to like handle it when it changes, when it's not as it used to expect. In terms of application development, S3 data wasn't really single-stop shop for all because of all this lack of capabilities that I explained earlier. And we started to have consumer team and services building separate stores than the main one that we had on S3. Some stores were built also because there was a lack of data compaction. So when Kafka writes data into S3, it writes a lot of files quite often, and these files are small and they're numerous and they're not very well consumable by applications. And so, yeah, it had become a little bit of a pain. And finally, we didn't have good support for data evolution. I did point on that a little bit earlier, but schema evolution wasn't supported out of the box, and it was prone a process that was prone to error to actually update data and these kind of things. So on that note, I'm going to pass on to Andreas, who will talk about our new Lakehouse architecture that solves a lot of these problems.
So yeah, at Rokt we have the data lake, we have the data warehouse. So what do? We mushroom them together, call it the Lakehouse, and we're done. Yeah, simple as that. But I think the Lakehouse architecture is a pattern that's been emerging in the industry for quite a while now. And our previous architecture has brought us where we are, but I think once the current driver really starting to slow us down, it's really needed to revamp our architecture right there. The Lakehouse, generally speaking, it is a data lake and a data warehouse, and tries to pick the good parts, inherit some of the bad ones. Generally speaking, it's like a data lake. So we've got a separate computer storage, which means you have a couple of files in the stream, and whenever you want to query that, you have to spin up your cluster to query that, whatever that is. Teams have to be their own query engine, so there's not a centralized service. Some new queries you have to actually run your query, or you run your query engine, which is great because at Rokt we actually have three different query engines supported at the moment by the teams, and we want teams to still be able to use the teams that they're familiar with. So in the data, in the machine learning space, we're using Flink, the reporting space, we're using Spark, and we've got a couple of teams also just using it as of today. So it's really important for us to have teams still using the tools that they're familiar with. And also the other good thing about the data lake or the lake and the Lakehouse is that the sky's the limit, S3s are limited, there's so much data we can store. Not everything correct is another question, but at least you can throw money at the problem and just keep ingesting data. On the other hand, from a data warehouse, we could have like a Lakehouse architecture to have its support for structured data. So it's not as flexible as a data lake, but at least we have the guardrails in place to actually say these are the schemas in my files that I can evaluate, evolutionize it. We also have discoverability for teams, because you can go into our Metastore catalog and you can see every table, every field that's there. Very much like a database with relational tables. And we also save metadata, which supports the underlying queries or the query line attributes. So whereas on a data lake, it might be really hard to actually narrow down specific query to which query because it's just files on S3. In the Lakehouse, we actually have that additional metadata, and and the query planner can make smart decisions about how to query and how to queries. And the other cool thing is asset consistency, which basically means that if you have writes, if you have constant writes on a lakehouse, but writes will not create any conflicts on the reader side, which was a problem that we had before in our data lake. Because whenever we ran a compaction, the compactor would just overwrite files. It would be a temporary state where there's multiple files with the same data on the data lake, and reading queries would fail, and we had to rerun them. Whereas with a lakehouse, we have that structure in place where changes are actually executed atomically. So typical lakehouse features, these were actually the features that we were looking at in the lakehouse when we evaluated which framework to use. Was the support for multiple queries, already mentioned, we have Link, Spark here, and already a few other things support. Schema evolution was really important for us because we just started migrating a lot of our communication between services onto Kafka using the schema registry, which basically makes sure that teams can't reduce backwards encryption changes on our shared Kafka topics by applying schema evolution rules. Only add a new field, can't remove the required field, things like that. And so we really wanted that to be end-to-end from our Kafka topic or from the interface between our services right into the lakehouse. Smart query plan optimizations. We wanted those queries to be reasonably fast. We did a whole thing on benchmarking just to make sure that whatever we do, we actually can cope with our demand. And we really wanted to optimize this storage so we can avoid the small files problem where it was just infeasible to query data over like a large range. The last feature, and that one's a very interesting one, is the flexibility to support different query patterns. So mostly looking at are you optimized for reads, do you optimize for writes, and tune that per table about is this a table where it's very important for us to get fast or very low latency reads, and we are okay to put the effort onto the reader to actually reconcile things. Whereas there's one of those topics where we really want to take the lead on the right part, and we say, okay, the read has to be fast, the write can be slow. So came up with all these great features, looked at the market and said, well, there's about 3 different frameworks, Apache Hudi, Apache Iceberg, and Delta Lake. 2 of them are open source, Apache Hudi, Apache Iceberg. Delta Lake at that time when we did this was semi-open source, so we're talking about Delta Lake 1, where a lot of the core features were open source, but a lot of the enterprise features were not open source, and you couldn't use some of those advanced features without paying Databricks. We did a whole evaluation, but as a company, we really wanted to go with an open source tool and avoid the vendor lock-in. Now, speaking as of today, about 2 or 3 weeks ago, they open sourced Delta Lake 2, which has all the cool features. So if we were to read this decision today, we might, come up with a different outcome. But for now, we've made our decision 3 months ago, 6 months ago, and we're still happy with the decision. But just keep that in mind if you ever going to evaluate the Delta Lake, or if you're Delta Lake 1, consider upgrading to Delta Lake 2, so that's really cool stuff. So really for us, I think it was a decision between Apache Hudi and Apache Iceberg. We looked at that. And I think the easiest comparison is to say is Apache Hudi comes with the batteries included, and the batteries are in the toy, EQ ready to go, and it's very opinionated, and a lot of the maintenance tasks are taken care of for you already. Apache Iceberg, on the other hand, comes with the batteries, but you've got to put the batteries in there. So there's a lot more operational overhead in actually operating it. At Rokt, we have about 4 or 5 different groups of use cases, and we compared both Apache Hudi and Apache Iceberg, and we actually figured out that for us, it was more beneficial to be able to tweak a lot of the operational aspects, depending on our use cases, which is why we opened Apache Iceberg. But overall, feature-wise, they're very, very similar, and it's a very actively developed space. So, a feature that isn't there in Iceberg, but it's in Hudi, it's very likely it's going to be in Iceberg in a couple of months' time. So, we looked at the features, we said, well, our feature list, looked at it and said, well, all of them ticket. So I thought, okay, well, now let's just benchmark them and figure out which one we use, because surely that will help us, and it's a good indicator. So we ran a TCP Xpd benchmark, which is, I think, TPC. Have you heard about TPC? Yeah. So it's an industry standard. They've got about like 20 different benchmarks. And the whole idea is that vendors can compare their product against another. It's 10 different ones. We decided on TPC Xpd. We ran it with all the screen various configurations, and at the end, but in the end, it gives you a number, and this is what it looked like. So, modified BBQ PM at SF means how many queries were we able to run per minute. You can see all the open source tools, they're all the same. Deltabricks was a bit quicker. Compare that with the cost per performance. It's the same story again, like Iceberg Goody at the open source Ultimate version 1 were all very, very similar. And again, the commercial offering of Deltabricks was had a certain edge. So we looked at it and said, well, features are very similar. Benchmark is very similar. It wasn't really helpful for us. So what we did was we just implemented both Apache Iceberg and Apache Goody, and then running production parallel running for right on, collected some data, and then finally made the decision that Iceberg was for us as a company better choice. The way how it works here at Rokt is at a very high level. We've got our Kafka consumers or Kafka producers. It all goes via Kafka, and we wrote two components. One is the Delta streamer, which basically listens to Kafka, processes those messages from all the incoming topics, bites into our Delta lake. We at the moment integrate about 200 different data sources, which averages about 500,000 events per minute, with a peak of I think 750,000 a minute. And that is a constantly running EMR cluster, which just uses data. Our target end-to-end SLO is about 15 minutes. So we want events once they're in Kafka to be ingested in the data lake within 15 minutes. And looking forward to like in the future trying to get that more down. The other component we have is the maintenance cluster. Typical, but there's like a lot of optimization potential that you can do. So once a day, we spin up another EMR cluster to run our action jobs, to run our manifests and all of that, just to make sure we're getting those sweet little big files. All of this is saved on S3 using Glue as a metastore. And down here, we've got all our happy consumers connecting to the metastore and connecting to our data lake. And yeah, that's it. It's live. Our data ingestion is running in production. We're starting to migrate our consumers over step by step. We have full end-to-end visibility, and as you can see, the majority of it is green, but we still have a couple of curves that we probably need to optimize in the future. But yeah, that is our data lake. Lakehouse.
So do you use
Can I give you this?
Spark? Hello?
Hi.
So do you use Spark cluster to support your Lakehouse?
Yes, so we're running a Spark cluster with Spark structured streaming, and we listen basically from Kafka into the Lakehouse.
Do you use AWS?
Yeah, so we are using a market. Not this one. So for that cluster, we're just using AWS EMR.
Can you give us an example how the Lakehouse supports your machine learning model?
Yeah, for sure. So we ingest all the data. We soon will be ingesting all the data that's required for the machine learning. And so as part of the Kubeflow pipelines, they're basically spinning up a Spark cluster to query the Lakehouse, get all the data they need, and then take it as input into the Kubeflow Tensorflow and providers. There's a couple of initiatives in the future which might take us either way, talking feature store and then seeing how the feature store will actually interact with the Lakehouse. But yeah, we'll look forward to integrate that as well.
One more question. Are you still using Redshift as a warehouse?
We do. We're having an initiative at the moment to actually reconsider whether we should continue using Redshift or not. I think a lot of the pain points that we had is that we had a lot of consumers, and the first thing they do is, well, I want to run a Spark job. I need my data. Well, I'll just run a big Spark Redshift unload of like 5 tables, and then I start my Spark application. And we have a few other ETL jobs that are doing very similar things. So what we're doing at the moment is we're trying to push all the ETL and batch processing jobs into the data lake. So, you are using your own Spark cluster and just use the Lakehouse instead of Redshift.
Do you use Spectrum?
We are using Spectrum for some use cases, yes.
That's fine. The idea is you can throw it.
So I don't get a database stack like Focus SSS, what type of SQL are you using? Database or not stack?
Oh yeah, so I mean this whole Lakehouse is only for our batch processing. We have ETLs in our offline processing space. We are, as Corey said, we are bringing in cool juice, and we are using a lot of AWS DB, a little bit of a real-time space. But we're also using Postgres, Redis, various other databases.
Quick question.
Right. That's it. It just doesn't matter if you.
It's
designed to bounce. Yeah.
I just had a quick question around your use of Glue and the metadata catalog and general data catalog, and how all the various teams are, I guess, using that to figure out which files to query, and how are you finding that, and and it's just comprehensiveness with tagging and sort of like access-based policies and stuff like that. Can you tell us a little bit about what your experience there is?
Yeah, absolutely. So we are using Glue as our meta store, and we are using Iceberg to sync into the meta store. Originally speaking, it doesn't store a lot in Glue, it just stores the schema and it pointer to the Iceberg manifest file. So the majority of data is still maintained within the Iceberg world and not in the Glue world. We don't use Glue for ACL or anything like that. And we also don't use Glue for tagging. We are, in our long-term roadmap, we are looking at, what's it called? Nessie. We were looking at Project Nessie in order. So in Project Nessie, we basically, we all use equal stuff, version control. You can create a branch of your data, check out the branch of the data, see what your data is like on that branch, and if you're happy with the data, you can commit your data in one atomic transactions back to your data store. So we probably most likely go with Project Nessie. To do that, although that is not something that we're doing as now, and it's something that we want to look at in the future. Just on that note, by the way, actually Iceberg also supports time traveling, so you can actually say, I want to create my data as it was last week. We're not going to do that because of GDPR, at least not for the majority of our data, because it doesn't work with our data deletion rules. We're probably going to use it for our CSC data, so everything that's not user data, we're looking at using it for. That's another cool feature. If you can use it, it's pretty cool.
Any other questions? Otherwise, we can catch them up to the break. But round of applause. Thank you very much. Yeah. Well, anyway, thanks so much. That's it from the another installment of the Sydney Data Engineering Meetup. Thanks everyone for rocking up to Rokt. And see you all at Data Edge Bites. We're gonna make sure you don't leave without getting yourself a ticket. No, all good.
But no, I reckon it's going to be a lot of fun, and really looking forward to it. But we'll have probably at least a meetup or two before then. So see you at the next one. Ciao for now.